So let's look at another idea from Unit 1, which is the idea of transformations. So my favorite way to do transformations, I think the most convenient way, is by using a table. So even if I'm given a graph that I want to perform some transformations on, I'll take that graph and make a table by just picking some convenient points on the graph, and then I'll transform the table to get a new table, and then I'll just replot that new table. So with transformations, tables are definitely the way to go.
Love tables.
Love tables. That's Miss Cross in the background. Again, I'm noticing a theme here for the Unit 1 notes. Miss Cross in the background, being fresh. So I'm just going to make up a table for this function f of x. So my x values are -3, -1, 0, 3, and 7. My y values are -2, 0, 5, 0, and -8. So I want to talk about how I could transform this table, or transform this function into a new function. So I'm going to make a new function g of x. And my new function g of x is going to be equal to f of x minus 3 plus 2. So my new function g of x is related to my f of x, but I'm just going to be changing the values in a certain way. So we've got to look at this transformation and be able to identify what the -3 and the +2 are doing to the graph of f of x. Well, that +2, that's outside of the whole function here. That's the translation that moves the function either up or down. It's a +2, that's going to move the function up too. Now this -3, that x minus 3, that's in parentheses there. So you probably remember from Algebra 2 that the shifts that happen inside parentheses that affect the x direction, moving the function left to right, they kind of work in reverse the way that you think they would. So that -3 actually moves the graph to the right 3. So once I've identified what the transformations do, I need to apply that to the table of f of x to create a new table for g of x here. So if the function is moved to the right 3, that means every x value, I'm going to add 3 to it from my f of x table. So I go down the line, and every x value, I'm going to add 3. That shifts all those x values to the right 3. And if I move the graph up 2, I'm going to take all the y values, and I'm going to add 2 to all of them. So I get 0, 2, 7, 2, -6. Now, if I plotted that new table for g of x, I would get the f of x graph, but it would be shifted to the right 3 and up 2. So again, I mean, I could do that straight off of the graph, but it would be kind of difficult, oftentimes, at least for me. So I find that using the table and applying the transformations to the table make this way easier, because then I can just take my new table and plot my new table on a new set of axes. So let's look at one more example. Let's take, make a new function. Goodbye, Ms. Grass. Oh, now we have Mr. Marano walking through here.
How's it going?
Yeah. So our function h of x is going to be -3 f of -1/2 x. So again, first we have to identify what these transformations do, and then we have to apply what we've determined to our f of x table to create the h of x table. Okay, well this -3, that's multiplying the entire function, the y values, because it's on kind of the outside, it's multiplying f, which is really just the y value. So that's going to multiply the y values by -3. Now let's think about what would happen if you multiply the y values by -3. Well, everything would be 3 times as big, but the negative would also give us a reflection. So that's going to be a stretch because we're stretching things by a factor of 3, it's going to be a stretch and a reflection. And I should be saying the direction here. This is vertical, since it's in the y direction. So it's vertically stretching by a factor of 3, and we're getting a reflection over the x-axis, because we're reflecting vertically, which means we'd reflect over the x. Now, this -1/2 on the inside, again, it's affecting the x direction. It's inside parentheses, so things are going to happen in reverse of what we think here. So since it's -1/2 x, that'd be like dividing all the x values by -2 is what it looks like. So really what we're going to do is we're going to multiply the x values by -2. So we're really doing kind of like the multiplicative inverse there. So it looks like that it would be cutting all the x values in half, or multiplying the x values by -1/2, but we're really going to do the multiplicative inverse of that, which would be multiplying by -2. Okay, so once we've identified those transformations, then we can make a table for our new function h of x. So I'm going to multiply all the x values by -2, so I get 6, 2, 0, -6, -14. And I'm going to multiply the y values by -3. So I would get 6, 0, -15, 0, and 24. And then I could plot the table that I have for h of x, and I would have a perfect graph of my function h of x.